Here we'll look at factoring expressions when a does not equal 1 using our calculator. So we may use the fact that an x-intercept may be rewritten as a factor of a polynomial expression to help us factor an expression. So that goes back to stuff we've learned before. As an example, if we know that x equals -2 is an x-intercept or a solution to a polynomial equation, we know that x plus 2 must have been a factor. So that's the idea that we're using here. So number one, suppose we're asked to factor x squared minus 6x minus 7. Now I would expect you to be able to factor that right now by looking at what multiplies to -7 and adds to -6. So I'd expect you to be able to do that. But let's look at the graph and the table to kind of introduce this idea that we're talking about. So if we have our x-intercepts here, this is -1, 0, and over here is 7, 0. So those are our two x-intercepts. With the table, with x and y in our table, notice that when you're on the x-axis, so at -1, 0 and 7, 0, notice that that means that your y value is 0. So in a table, what you're looking for to find an x-intercept is for a y value to be 0. And we see that here in this table, that when x is -1, we get a y value of 0. So think about what that means for us. It means -1, 0 is an x-intercept, which means x plus 1 is a factor of x squared minus 6x minus 7. So we know that x plus 1 times some other polynomial must equal x squared minus 6x minus 7. So once you get that one x-intercept, you can use that, and now we're going to look at what can you multiply x plus 1 by to get that resulting polynomial. So it's not as hard as it might look. If you look at FOILing, first outside, inside, last, when you take x and multiply the first term over here in the second parentheses, you need to end up with x squared. Well, isn't x times x, x squared? So there you go. And then in that second spot, the last term has to multiply to -7. Well, 1 times what gives you -7? Isn't it -7? Now, just to see that that works out, we're saying that x plus 1 times x minus 7 should equal x squared minus 6x minus 7. So if you multiply that out, x times x is x squared, x times -7 is minus 7x, 1 times x is plus 1x, and then 1 times -7 is -7. Notice these two terms combine to -6x in the middle, and that's the polynomial that we were looking for. So that's how you can use your x-intercept turned into a factor to find the second factor of a polynomial. So the next one, x squared plus 8x plus 12. Well, in our calculator, we'll put in our function x squared plus 8x plus 12. Press enter, and we don't care where we're starting the table at. Okay, just press enter until we get down to the OK, and our table comes up. And remember, what we're looking for is, just like in this last table, we're looking for a y value of 0. So where does a y value equal 0? You can scroll up or down. Oh, and right there, notice that I get, when x is -2, we get a y value of 0. So that tells us that -2, 0 is an x-intercept. Now think about, what does that mean as far as the factors go? It means x plus 2 times some other polynomial must equal x squared plus 8x plus 12. So x times what gives you x squared? X times x gives you x squared. And then 2 times what gives you the last term? Positive 6. Now what's kind of weird here, that it might be kind of confusing, it's like, well, we don't have to worry about anything else. We're just literally saying x times x is the first term, x squared, and then 2 times what gives me 12. Yes, that's all you need to do, because when you FOIL, that's all you're looking at. The first terms have to multiply to x squared in this case, and the last terms must multiply to 12. And we know that x plus 2 has to be one of the factors, because negative 2 is an x-intercept. So it literally is that easy. Just to check it out now, if you were to multiply that out, so FOIL it out, x times x is x squared, x times 6 is 6x, 2 times x is 2x, and then 2 times 6 is positive 12. Those middle two terms combine to 8x. So that's what we want for our polynomial, so we have the factored form here. Okay, going on to the next one. Now they get a little bit trickier, because now we have a coefficient of the x squared that's not equal to 1. And this is the real reason to learn this method. So what we'll do is in our table, we'll put in our function 2x squared minus 13x and plus 6. I'm not going over the calculator steps because this is the same as graphing functions from earlier in the course. So I expect you to be able to use your calculator at this point. Okay, we'll press enter. Again, we don't care where the table starts. We can scroll up and down to find a 0 for the y value. So we're looking for a y value of 0. Well, and notice what happened right here. From 0 to 1 for the x values, the y values went from positive 6 to negative 5. Now think about what that means. To go from positive 6 to negative 5, we must have passed through 0. So what that means is there must be an x-intercept between 0 and 1. So it might be 1/2, 1/3, 2/3, 3/4. Okay, we don't know yet. So let's keep scrolling until we find a 0. Oh, and right there, when x is 6, we get a y value of 0. So we know that 6, 0 is an x-intercept. So think about the factor would be the opposite sign, x minus 6. So that means x minus 6 times something, some other polynomial, your second factor, must equal 2x squared minus 13x plus 6. So x times what is 2x squared? This one's a little tougher, 2x. That'll give you 2x squared. And then negative 6 times what will give you that last term of positive 6? Well, negative 1. So there's your factored form, x minus 6 times 2x minus 1. And just very quickly to FOIL that out, just to show you how that this works, x times 2x is 2x squared, and then x times negative 1 is minus 1x. Negative 6 times 2x is minus 12x. Negative 6 times negative 1, positive 6. So notice that these two terms in the middle will add to negative 13x. And that's the polynomial that you're looking for. So here is the factored form. Now the other thing I want to point out is, remember in the calculator how we were scrolling and I mentioned how between 0 and 1 the y value went from positive to negative? Well, think about 2x minus 1. If you were to set that equal to 0, you would get 1/2 for the x value. And isn't 1/2 between 0 and 1? So that's another thing you can do, is if you can't, so let's just suppose we couldn't find 6, 0 as an x-intercept. We could have seen that between 0 and 1 there's an x-intercept, and then just play a little game of substituting in numbers between 0 and 1. So you don't want to go too crazy and say, okay, what about 0.4738? Well, no, don't go that crazy. Just think about basic fractions, like 1/2, 1/3, 2/3, numbers like those. Okay, and then part C. Again, this is the same idea as part B, so I want you to try that one. And I'll put the answer up as well as the answers on the last page, because those are just some more practice questions. So pause the video and try C and then everything on the second page. Okay, so there's your answer to C and then everything on the last page. So notice how I find the x-intercept first, write the factor, and then find that second factor by FOILing. So it isn't too bad once you get the hang of it, and hopefully that'll help you factor, especially when a does not equal 1. So meaning like these, you have a 3x squared, a 4x squared, a 3x squared. This method can really help you with those.